All right, guys, hey, we are on page 7 of the packet, so I'm just going to keep practicing some of the normal CDF problems that we started looking at in class this week. What I do have here for you is I have some steps that I need to make sure that you do. I do need to see all 4 of these to receive full credit on a test in our class, on the AP exam, on everything. What you should have read about and put in your reading guide is this thing that our textbook refers to as state, plan, do, and conclude. And the biggest thing that people don't do in problems like this page are they don't show enough work. And there is a lot of very specific work, step 1, step 2, step 3, that you need to show in order to gain full credit on problems like this. So basically what state means is define stuff. And when I do this question, I'll refer up to this. Plan means you show all your work, you find a Z-score, you do conversions, you have correct notation. The do is when you actually use your calculator. Or we talked about you can use your calculator or table A to look up proportions. And then step 4, very important, conclude. Remember the AP part of AP Stats is not calculating the number, it's explaining what the number means. So once you come up with an answer, you must write a sentence telling me what that answer means. So yesterday we talked about in class Rafael Nadal and his speed, the speeds of his serves or something like that. So the context is what you're going to be mentioning in your conclusion sentence. Let's jump right in. In a certain college, we've got IQ scores of students. And remember, I told you that we're going to be given important information, and you remember what this notation is. We cannot do our 68, 95, 99.7. We cannot use table A. We cannot use normal CDF if we don't know our distribution is normal. So this is very important given information. This is symbolic notation. It tells us approximately normal. This is the mean. This is the standard deviation. And question number 1 says about what proportion of students have IQs less than 95. So step 1 is always show a sketch. And it doesn't have to be beautiful. You don't have to make this like super pretty, but you know what's supposed to go in the middle, the 112, and then we go 1, 2, 3, 1, 2, 3. I would even say you don't even have to label the x-axis every single tick mark. I just want to show the shaded area. But if I do need to draw a line at 95, knowing that my standard deviation is 12 here, that would be 100. This would be what, 88. This would be 76. Just so I know where exactly to draw my line. My line's supposed to be drawn at 95, so I'm right here. I'm a little bit more than 1 standard deviation below average, which means my Z-score is going to be negative. But remember, I should have like some sort of a estimation in terms of what percentage that is. Something a little bit less than, I don't know, 20, 15, 10. This is a small shaded area, definitely less than 50%. Okay? So how do I show all my work? So first step, show the sketch. I need to state some stuff. I'm going to be using an X in my work. So I'm going to define what X is. And in this case, what are we looking at? IQ scores of students at this college. If I were defining X from the Rafael Nadal question that we did yesterday, I would say miles per hour of Rafael Nadal's first serve. It was units. In this case, we don't have really units on IQ that I'm aware of, but anyways. And what is the question asking me to find? Where is the actual question here? Here it is. Less than 95. That's why I shaded the way that I did right there. So less than 95, I'm going to state symbolically, this question is asking me to find the proportion where X is less than 95. Okay, so there I drew my 95. And what I have to do now is I have to convert this thing to a Z-score. So probability Z less than, and notice that when I'm converting to a Z-score, my X changes to a Z. That's not a typo, but I'm doing 95 as my X value. What was the mean again? 112, and what was the standard deviation? 12. So what I'm going to do here, I just realized I have an error in my key, so I need to actually calculate this Z-score real quick. 95 minus 112 divided by 12. We get a Z-score of negative 1.41. That looks about correct according to the way I drew it. like a little bit more than 1 standard deviation to the left. That seems good to me. 95 minus 112 over 12. Remember, since these are our notes, if you're wondering how I did that, remember the z-score formula is x minus the mean over the standard deviation. The x is where we drew our line. This question, the x is 95, so there it is, and there it is. Okay, so from now, I believe I've done all of my stating. I've defined what x is, and I have restated symbolically. This is exactly the notation that you need to show. This is symbolically what the question is asking me to do. Find the probability or the proportion that x is less than 95. That's an IQ score, and the IQ score is defined up here. So now I'm going to convert my x to a z-score so that I can use table A, and I'm now looking up negative 1.41, or I'm going to use the calculator to do normal CDF. So when I look up table A, let me find negative 1.41. Where's table A? Let me show you how we do this. On the negative page, make sure that it says table A. There is a table B and a table C. Don't get those confused. But I'm looking up negative 1.41. Or I guess if you round it, it's negative 1.42. That's okay. I'll go negative 1.41 right here. 0.0793. And remember, do we have to do like that weird subtracting from one thing? Not exactly, because this is the shaded area in my picture that I drew that I'm interested in. And remember, table A always gives you the area to the left of that z-score. So in this case, my answer is 0.0793. I will remind you how to do that in the calculator. In the calculator, what you're going to want to type, if you are verifying with your calculator, you're going to go to normal CDF. And we are doing negative infinity. That's the lower bound because we're shading to the left. Remember, the z-score that I stopped at was negative 1.41. I guess you could also use negative 1.42. That's okay. And since it's a z-score, you're doing 0 and 1. And it will give you a number very, very similar to this, slightly different because your calculator is a little bit more accurate. If this were a multiple choice question, remember you could also do normal CDF. Still negative infinity. If we want to be in terms of IQ scores, I stopped shading at 95. That was my X value. The mean IQ score was 112. That's an IQ value. And the standard deviation was 12. And that will give you the same exact answer in the calculator. Either of those is fine. Just don't get confused because these are all in z-score units, if you will, and these are all in IQ score units, if you will. You do not have to write this onto your work. That's called calculator syntax, and you don't ever get credit for showing calculator syntax. Just fun fact. So this is our answer, 0.0793. And remember the most important part of the problem. Conclude. Do you know what this means? 7 what? 8% what? 8% about 8% of the students at this college have an IQ score less than 95. So I'm going to write that. About, I'll put 7.9% of students at this college have an IQ score less than 95. It's literally like copy paste. You're basically just recopying the question with this answer. If you left it as a decimal, that would be okay too. You would just say about 0.0793 of the students at this college. That would be fine. Anyway, so make sure for full credit you have stated stuff. That means define X and restate symbolically. The plan is showing all the work, which includes a z-score calculation. The do part is actually coming up with an answer. And the conclude part is probably the most important. Write the sentence. Let's try another one. Find the percent of students with IQs between 110 and 130. I'm going to get a new sketch just so it doesn't get confusing, even though it's all the same numbers, essentially. 112. Here's 110. And here is 130. And we've got shading in the middle. I definitely don't want to use table A for this problem just because remember what table A does is we first find like this area and we subtract the two and it was like kind of annoying. So I'm just going to do lower bound, upper bound in the calculator. How do I show all this work though? So I have a little bit of an idea. I think this is probably more than half, more than 50% of my bell curve, because I'm just subtracting away these two tails. But I'm again going to define what my X is. It's the IQ score. We already defined it above, but I want you to have in your notes that yes, every single question you must define the X. And in this question, it's asking me a little bit differently. It's not less than or greater than, it's in between 110 and 130, and it's an IQ score. So I'm gonna put, let's see, 110 is less than X is less than 130. Just write it as a compound inequality. Okay, so mirroring like what I did in this one, I've drawn my sketch, I've shaded my area, I have defined X, and I have written in symbolic notation what the question's asking me. What's the next thing I have to do? Convert to a z-score. And yes, you can do both of them at once. So I'm going to change this to probability. I'm going to do two different z-score formulas. So 110 is the first X value, subtract the mean, divide by the standard deviation. And make sure that you got, once you're converting to a z-score, your X changes to a z. And I'm going to do the same formula over here. So 130 minus 112 divided by 12. And I can crunch those two z-scores really quick. That gives me a z-score of negative 0.16. I'm running a little bit out of room, my bad. And then when you do this one, 130 minus 112 over 12, you get positive 1.5. Okay, so I'm not going to show table A just because it would be a little bit confusing. We did do an example using table A where there are two bounds. What you would do is you would look up table A, this z-score, and remember that would just tell you this shaded area right here on this tail. And we would end up subtracting that away from the area when you looked up this z-score, which represents from here all the way over. That is a little bit confusing though, so I'm just going to remind you how to do this in the calculator. Normal CDF. In this case, lower bound, here's my z-score. Upper bound is another z-score. I'm not using infinities for this one because I'm only shading strictly between two numbers. And then remember, since these are z-scores, my mean and standard deviation are going to be 0 and 1. Yes, you could change this number to 110, this number to 130, this number to 112, and this number to 12. You'll get the same exact answer. Excuse me. Anyways, throw that in your calculator and you end up with 0.8857 or something very close. I believe when I did this example, I used the table here. Your calculator will be slightly more accurate, but something between 88 and 89%. That's our answer. And remember, most important part, here's our numerical answer. Can you write the sentence? That's the AP part of AP Stats. So we have about 88.6% of students at this college recopy the question, have an IQ greater than, or no, in between 110 and 130. Okay, another one. Percent of students higher than 135. Okay, another sketch. This just helps us with our common sense. I've got 112 right in the middle. 135 way out here. Greater than that, we're looking at a very small percentage. You agree? So I'm going to first define my X. It's the IQ score. I already wrote it above. I would not put 3 dots if this were the AP exam, but they wouldn't also have you write the same thing over and over and over again. Just know that you have to define X. I want that to jump out at you in your notes. Probability that X is greater than 135 is the question being asked. It's right here. And that's why I shaded this direction. I'm going to change this to a z-score. The mean is still 112 and the standard deviation is still 12. That gives you a z-score of 1.92. You should have a pretty good idea that that is a really small shaded area. Remember, something's considered an outlier if it's more than 2 standard deviations above average. This is pretty close to that. Anyway, so you can look up in table A the z-score of 1.92. Just remember that table A is going to give you the area to the left, so you're going to have to subtract that from 1. If we want to go the calculator route, I'm going to go normal CDF. I'm just writing this in the notes so that you guys can follow along. You do not write the calculator syntax within your work, but for your notes, it's probably a good idea to write it down. Lower bound 1.92, upper bound infinity. Since it's a z-score, we're doing 0 and 1. Yes, you could also put 135 here, shade to infinity forever, and change this to 112 and this to 12. You get the same exact answer. This is going to give us a pretty small percentage, which is 0.0274. I believe I was using the table A to calculate all of these numbers, so your calculators are probably a little bit more accurate, but you still get the point. We're close to 3%, a little bit less than that. Again, what does this numerical answer tell us? About 2.74% of students at this college have an IQ greater than 135. Cool. So 1, 2, and 3 were pretty much exactly the same. Slight difference in the way you type it in because the shaded areas and the bounds looked a little bit different. Number 4 is a little bit different. What IQ must you have to be in the top 10%? Does this jump out at you as an inverse norm question? We have the percentage. In all the other questions, we were looking for the percentage. In this case, we have the percentage. This is when you're going to use that other button in your calculator. So pay close attention on this one. I'm still going to draw a sketch. Really briefly, I've got 112 right here. Top 10%. I do not know what this x value is. This is an inverse question. I'm trying to find the x. I know the percentage. So the inverse norm is what's going to help me with this. I'll talk you through the calculator in just a second, but first I'm still going to start by defining all my stuff. X still represents the IQ score of a certain student at this college, and I do not know what the x is here. That's what I'm going to be solving for. Okay. Symbolically, they're wanting me to find the probability that x is greater than some number, which I don't know, so I'm just going to call it x sub a. And that equals the top 10%. So this is something very different than what we've been doing. Remember, I've been recopying symbolically basically what the question's asking. Find the probability that x is greater than 135. I don't really have that here. I need to find the probability that x is greater than, I don't know this number, but I do know that the probability, the answer, the percentage is 0.1. And I want you to know that it is also correct to write the probability x is less than some number equals 0.9. I hope you can understand that that is also correct. Top 10% technically means 90th percentile. That means you scored better than 90% of people, right? Just keep that in mind. Either of these ways to express this symbolically is correct. So there's something a little bit different. What I'm going to do is, remember, when you're doing your AP exam, you're trying to convince whoever's grading your paper that knows nothing about you that you know your stuff, right? So I want to communicate to whoever's grading exactly what I'm thinking when I'm looking up. I'm going to find the z-score for top 10%, which is the same as the 90th percentile. And what that z-score is, you can look on table A. Let me show you. I'm going to go to table A, and for the 90th percentile, remember that the table always gives you shaded area to the left. So what I'm looking for is this number to be 90, which would mean this number is 10. So I'm looking through all of these really annoying 4-digit numbers, and I'm trying to find the closest one I can to 90%. I believe we're right here. What is that z-score? I'm going to use 1.28. That is pretty close. I'll show you how to get that number in your calculator in just a second. But using the table, I'm going to use the z-score of 1.28. So I'm going to say the z-score is 1.28. Now, I'm pretty sure we have a z-score formula, you guys, and I think that we have all the information except for the x. The z-score is 1.28. The x I don't know. I didn't know where to draw the line. I haven't labeled that x yet, but I still know the mean is 112, and isn't the standard deviation still 12? You can solve that thing. I believe solving that, you get x equals 127.36. I do not think that you can get a decimal IQ score. So to be in the top 10%, we can't truncate this and round it down to 127 because you have to have a score better than 127 to be in the top 10%. So we need to round this to 128. That happens to be the IQ score that cuts off the top 10%. Again, if you cut off 127, that'll be a little bit shy of top 10% here. So we have to round that number up to be within the top 10%. I don't think you can get a decimal IQ score. So how do I conclude this? And then I'll remind you how to do that in the calculator or show you. To be in the top 10% at this college, a student must get an IQ score of 128 or higher, I guess. Sorry, my writing got a little bit messy there. How can I find this number in the calculator, 1.28? So inverse norm. I told you how to find that in the table. If you need to rewind and watch it again, go ahead and do that. But inverse norm, which is in the same exact spot of your calculator where normal CDF is, if you want to find the z-score, which the z-score is important to find, you have to show the z-score in this to get full credit for showing all the work. Inverse norm, the 90th percentile. So we're going to put 0.9. Remember, don't put the 0.1. That'll actually give you a negative z-score, which is not good because that doesn't match our picture over here. We want a positive z-score because we're top 10%. If you put in 10%, that'll be down here. It'll give you a negative z-score. So remember, the calculator wants to know the area to the left. So top 10% means 90th percentile. Anyways, that's the area it wants. And again, for z-scores, the mean is 0, the standard deviation is 1, and I believe that gives you 1.28. So you can find that in the calculator, okay? Fun fact, if this were a multiple choice question, you can also do IQ scores. You're still top 10% is still 0.9, but if you want to put in IQ scores, you would put 112 and 12, and it would give you the answer of 128. Fun fact. I want you to know how to use your calculator as a tool and as a resource. Okay, you guys, that was a lot. I'm out of breath. I'm sorry if I talked really fast, but I know you can pause, you can work together, you can ask questions to each other, and you can go back and rewind and watch something if you missed it or if I went too fast. But right now, I just have a little bit more practice for you, okay? Good job taking your notes. I'll answer all your questions next time I see you. Love you all.